Alright, I've got where we left off last time was this Pong game with the shockwaves, and then we added a couple tiny features, or fixed a couple tiny features. Sometimes it doesn't work on the first run, where, okay, it's bouncing, and then if it goes off screen, it comes back in the middle. That's not complete. It doesn't give us any countdown or any score, but it's nice. And then I fixed the bounce where sometimes it would go inside the paddle and jaggedly go back and forth. We just forced it to go the right direction, even if it's a little too far. So what I'd like to say is, what would happen if we add a second ball? This is going to be, at first, pretty easy because we've got the ball class. We can just make another one. I'm going to say ball 2. And then we'll make it start in a slightly different spot. I don't know, let's just say 200, 200, and let's see what happens. And then right now I'm going to say ball 2, but we'll add them to a list, and we'll make a list. I just want to show that with 2 quick lines we can get something going. Let's see how that goes. Okay, that's great. They're bouncing. Now obviously they are following the same rules, and if they go off screen, yep, they reappear. That's fine. It's a little too fast. Maybe the paddles could be faster. But they're missing one thing, which is they're not bouncing off each other. They would just completely go through each other because there's no collision for anticipating that. So let's work on that. First, I want to make a list, because if we're getting past 1, then maybe we're going to have 2, maybe we're going to have 5. And we don't want to hard code specifically 2. I don't want to say if this ball with this name runs into this ball with this name. I want to set up a system of collision that says, hey, if any ball hits any ball, they're going to bounce. So I'm going to make a list, and we'll call it balls. And then we'll say something like, okay, this means that however many there are, it's going to go through the list. And I'm going to change this guy to ball 1 because I don't want to have any name that's a little generic. Like when we had our first paddle, we called it paddle, but now that we've got more than one, we'll call it paddle left and paddle right. In fact, we don't even need to give them names at all. We could say, for example, this and this. Now, that's almost preventing us from making any mistakes, just like in case we were going to get lazy and use the names. This is saying, nope, you can't do that. Let me hit run to make sure I didn't ruin it. But it should work the same. Yeah, for some reason, like, there's a small percentage of the time where it just appears in the wrong place on the preview window on CodeHS. Okay, they're doing their job just fine. Okay, so now I'm going to make a collision in the ball class to say, hey, if any ball hits any other ball, we have to do something. Let's go over to the ball class. Let's shrink these guys for a minute in case we end up scrolling back and forth. We can make the paddle and shockwave collapsed, and then you can hit the little arrow to expand them again. So there's a bounce for the other guy. This is getting kind of big. It was always the biggest and ugliest in every version, but now it's going to get even bigger because we're going to say bounce off other ball, if something, do something, etc. So we might want to break this up into separate parts, like the shockwave could be a separate thing. We could say, hey, if you ever change direction, then just leave a shockwave. But let's see what happens. What we're going to need to do, or what I would like to do, is to say for ball and balls, like it's going to go through the list and say, am I hitting this guy, this guy, this guy? Remember, we have 2 now, but there could be a million. I saw somebody in class looking at a weird little game with a bunch of little items bouncing around. And we want to make this work for any amount. So it's not going to mention, oh, the other one, let's check the other one. It's going to say, let's check all of them, which means, I guess, I just thought of this, but we don't want it to bounce off itself. So if ball is self continue, I guess I was going to say pass. I think it would do the same thing. And then that means it's not going to accidentally bounce off itself. Maybe it would work without that. I don't know. Let's say if ball dot, I would really like to have a collide method so we don't have to test their x and our y and blah blah blah. So let's make a method, and we're not going to use the hitbox, which has been perfect so far. We've got a square hitbox around the ball because that works when it's hitting things on the edge. Like the top of the ball is the only thing that ever hits the ceiling, and the left of the ball is the only thing that ever hits the left paddle, even if it's going at different angles, right? But when it's hitting stuff in the middle of the screen, then that's not true anymore. The balls are going to hit each other at the corner, and then their square hitboxes aren't good anymore. So let's do a separate method for that, because we can always have a mix of like using the built-in stuff plus our homebrew stuff, and that's usually a way to take advantage of what's there, plus fix the, patch the holes, plus learn, and that's our main goal always, is to learn. So we can do that. So I'm going to make one called collide ball to sort of parallel the collide rect, and it's going to have self and other, because it's going to check, does my self circle overlap with this other circle. And what's it going to need? Well, I suppose we just want to test the distance between our radius, or our center and their center. And if that's more than the 2 radii, then we're not hitting yet. But if it's less than the 2 radii, then we are. You know what I mean? Like, no matter what angle the balls are hitting each other, they are overlapping if the center of one is close enough to the center of the other. And even though our balls right now are not moving in different angles, they're just going in 4 possible directions. I would really like to open that up later. So we could do the classic like Pythagorean theorem / distance formula, where we say I'm going to stretch it out over multiple lines instead of squishing it all into one. So dx equals self.x minus other.x and self.y minus other.y. And then, it's like the Pythagorean theorem. It's the a squared plus b squared, and then you square root it, I guess. So something like distance equals dx squared plus dy squared, and then we square root the whole thing, which means we want to import it. Oh my gosh. Okay. This is not as easy as I thought, right? And then we can say if distance is less than self.radius plus other.radius, then, or no, we can just say return that, because it's going to return true or false, like, are we close enough to bonk the other? Now, this is horrible. I don't like it. Let's think of a way to make it better, but let's try it first and then go from there. So if ball dot collide ball with self, then what do? We can't just switch the x or switch the y, because this is, when I say switch, I mean like go from positive to negative. Because this is encompassing all the possible ways they could bounce. This is like a guy coming from down here, hitting a guy coming from down here, in which case maybe they would change x and y. If you were going up and left and you hit a guy going down and right, then maybe now you're going down and right. But if you're, let's say somebody's coming from down and right this way, and then somebody's coming up and right this way, then they would bounce, and they're still going right. This guy would bounce up, and this guy would bounce down. So I think, and this is kind of a trick, but I think we can just switch their velocities, not from negative to positive, but I mean switch from one ball to the other. So that, like, okay, self.vx equals other.vx. And we need to do this. This is sort of a trick that came to me when I was thinking about it, but I think this works. And then the vy's do the same thing, because this will preserve, if they were both going right, now they're still both going right, or whatever. And if they're hitting from complete opposite directions, then they'll switch completely. And now I don't have to add anything to the update because this is in the bounce, and I don't have to add anything to the main loop because we already set it up. So let's try this. I think it might work. Well, never mind. Okay. So this says, okay, collide ball, and we send self, but then it doesn't know. Okay, so it has this idea of like, we need two balls. We need to send them our info so that they can compare to their info. But maybe we want to treat it as the other way around, like we're taking their info and comparing it. What would happen if we say, I think this might solve some confusion, I don't know, if we just switch self and other and these guys. Let's see what happens. I'm going for like the real simple solutions. You see, now I'm not adding any fancy stuff because I want to make it something quick. Okay, they still don't like that. Okay, so that wasn't the issue. That wasn't the issue. Let's switch it back, because if we have it like this, then it's more parallel with the collide rect from earlier. Sort of making our own homemade function follow the pattern of that other function, which we don't have to do, but it's nice. Because when I look at one, I want to have my brain change the minimum when I look at the other, even though it's not working right now. So what am I missing? Let's see what we're doing here. Okay. Oh, then all I need to change is this guy, because the other was the name of the parameter in here, but it's not the name of anything in here. We're calling it ball in here when we're going through this loop. That's all we needed, probably. Let's see now. Okay. Boop. Yep, that looked great, actually. They're not super likely to bounce. Nope, but they did. Look at that. That's perfect, I think. That one got stuck on the bottom in a weird way. Yeah, but that's actually perfect. So even though I made a dumb mistake a minute ago, that was correctly bouncing. If they were going straight at each other with like 180 head-on collision, then they would both turn around and go fully backwards. And if they were glancing off each other, then they would preserve the thing that needed to be preserved without overlapping. So this is actually perfect, this idea of, hey, I give you my velocity and you give me yours, which I guess would be the physics way to describe it. And I think it would even work when we do fancier angles later, but we haven't so far. This is missing one thing, which is the shock wave. When the ball bounces off side or paddle, or top or bottom, then it leaves a shock wave. And when they bounce off each other, they're not. So let's see if we can add that. We can easily leave one, but we need to know where. Like, what's the point? You know, is it the top left, the top right, whatever? How can we tell that? Well, that might be a little extra. Maybe it would have something to do with a distance, like going halfway. Yeah, actually, that would be the hard part. I'm going to leave that as an exercise for the reader because I don't want this video to be super long. However, let's look at one quick thing. I don't love the idea of doing square root because I think we probably don't have to. I think we can probably just say, what if we don't do it? Like, right now, our program is fine, and we're not worrying about like performance or anything. But I happen to know that square roots are, you know, much slower than other kinds of math. And if we can avoid it, then we might as well. And if we have a lot of things going on and a lot of shock waves, then I think my program might lose frames later. What if I had, you know, a dozen balls bouncing around or something? So can we do this without the square root? I think we totally can. Because this is, okay, what I mean is, we just multiply these guys as well. Maybe that's silly. Maybe it doesn't matter. Yeah, it's still doing the same math, like behind the scenes. See if we can get them to bounce again. Oh, yeah, they're bouncing just fine. And I love the idea of not using square root. We can even delete it from the imports. And just to be clear, I know that line is ugly, but the idea is that we are in control. We don't have to use the classic formula. We can just like do what we need and say, hey, instead of squaring it or square rooting it, let's just square the other thing. And this could even be simplified more if we assume that the balls have the same radius, which they do. But later we might have balls with a different radius. So we'll keep it for now. And that's it.